Revising index laws. The first index law says, when terms with the same base are multiplied, the indices are added. Simplify each of the following. As we have like bases here, we can add the powers, or the exponents. So 4 plus 3 is 7. That simply is x to the 7. In this case here, we have like bases. We can complete the bases first. K squared and k cubed, if we add 2 and 3, we'll have k to the 5. Their coefficients are 3 and negative 2. 3 times negative 2 is negative 6. In question C, we have our a cubed and our a to the 8. Adding 3 and 8, we have a to the 11. We have b to the 5 times b squared. Adding our powers, 5 and 2, makes b to the 7. You could also write this as b to the 7, a to 11, but probably the first one is the preferred option. In our question D, 2 times 5 is 10. M cubed and m squared, if we add the 3 and the 2, makes 5. And v cubed and v to the 7, 3 plus 7 is 10. Moving on to the second index law. The second index law states, when terms with the same base are divided, the indices are subtracted. Simplify each of the following. Let's check first. We have both numbers have base 6, which means we can use our index law to simplify. 8 take 2 is 6. So this is 6 to the 6. In our next question, 15 divided by 3 is 5. F to the 6 divided by f to the 2 means we subtract our powers, so 6 take 2 is 4. In question C, we have multiple variables, q and s. We'll complete our q's first. Q to the 4 divided by q to the 4 is going to cancel out. You're then left with s to the 5 divided by s cubed. Taking those powers away, 5 take 3 is 2, s squared. This one looks a little bit more complex. We'll have to simplify the numerator first. 6 times 3 is 18. E squared and e to the 5. We add those powers. 2 plus 5 is 7, so that's e to the 7. F to the 4 times f squared is f to the 6. All over 9e to the 4, f to the 5. Our next line of simplification of 18 divided by 9 is 2. We then have e to the 7 and e to the 4. We also have f to the 6 and f to the 5. So let's simplify our e to the 7, e to the 4. Divide means subtract the powers. So 7 take 4 is 3, and 6 take 5 is 1. We can write a 1 there, but there's no need to if we just write f. The third index law, any term, excluding 0, with an index of 0 is equal to 1. You might have heard of anything to the power of 0 is 1. So 6 to the power of 0 is 1. You also had 7 to the power of 0, that's 1. Or x to the power of 0, that's 1. Even things in brackets such as 2x to the 0 equals 1. In this question B, we have b squared, remains as b squared. The x to the 0 is 1, so your answer is b squared. 5y to the 0 really means 5 lots of 1. You then have times by 2h to the 0, the h to the 0 becomes 1, which means you have 5 multiplied by 2, which gives you 10. In the next one, we have multiply. In our bases here, x, which means we add our powers. So we have 3 lots of x to the 0 because 2 added to negative 2 makes 0. Your x to the 0 is 1, which means your answer is 3. The fourth index law, when a power is raised to another power, the indices are multiplied. Here we have 2 cubed raised to the power of 5. Our power is raised to a power, so we multiply the 3 and 5. 3 5s are 15. In question B, we have x to the 4 raised to the power of 3. We multiply these two together, which means it's x to the 12. In question C, we have 2 lots of x to the 6 to the power of 2. Let's simplify x to the 6 to the power of 2 first. Power to a power means we multiply that. So 6 times 2 is 12. We still have 2 lots of x to the 12. In our second bracket, we have x to the 2 to the power of 3. Multiplying 2 and 3 is 6. We have x to the 6. We can go one step further, because here we have like bases, and now we add our powers using index law 1. 12 plus 6 is 18, so it's x to the 18. In this case, we have a quotient with 2 brackets involved. So let's simplify the numerator first. 3 to the 8, we multiply, so 3 8s are 24. In our denominator, we have 5 to the t5 to the power of 2, so we multiply the 5 and 2 together to make t to the 10. Division means we now subtract these powers. 24 take 10 is 14. The fifth index law, when the base is a product, raise every part of the product to the index outside the brackets. What this means is this power of 5 must be distributed across the d cubed and the r to the 4, and the power to a power means multiply. So d cubed to the 5, 3 5s are 15, and then r to the 4 to the 5, 4 5s are 20, so it's r to the 20. In this next case, this power of 2 has to be treated on both terms, parts of that expression. So 3 squared needs to come first. T cubed to the power of 2, a power to a power means times, so 3 2s, 6. 3 squared could then be simplified to 9, and t squared can remain as it is, so it's 9t squared. J, m to the 4, w to the 6, all to the power of 4. So first is to apply the power of 4 to the j, and that's really j to the 1. So 1 times 4 is 4. Your m to the 4, 4 4s are 16. And lastly, w to the 6, 6 4s, 24. So w to the 24. This next one, we will leave the 3 first and write down 3 lots of, and now we will apply this power of 3 to the x squared. 2 3s are 6, 3 4s are 12. In our next bracket, we'll apply this 2 to the 2 squared. 2 times 2 is 2 to the power of 4. 2 times 3 is 6, so x to the power of 6. And 2 2s are 4, so y to the power of 4. Now theoretically, we can remove those brackets here, but it's not going to be a problem having them as they are at the moment. So 3 lots of 2 are 6. Now x to the 6 and x to the 6 we add, so 6 and 6 make 12. And y to the 12 and y to the 4, multiply means add, so 12 plus 4 is 16. Sixth index law. When the base is a fraction, multiply the indices of both the numerator and the denominator by the index outside the brackets. Simplify each of the following. So z cubed to the 4, 3 4s are 12, so z to the 12 over g squared is also applied to the power of 4, so 2 4s are 8. So z to the power of 12 over g to the power of 8. Question B, 2 to the power of 1 raised to the power of 3 becomes 2 cubed. P squared to the power of 3, 2 times 3 is 6, so it's p to the 6. Now our denominator, 3 to the power of 1 risen to the power of 3 becomes 3 to the power of 3. And e to the 5 to the power of 3. 5 times 3 is 15. So we're left with 2 to the power of 3, which you could write as being 8. P to the 6. And 3 to the power of 3 is 3 times 3 times 3, which is 27. E to the 15. The seventh index law is when the convention is that an expression should be written using positive indices and with the pronumeral given in alphabetical order. So here, a to the negative 3, or 1u to the negative 3 is really 1 over u cubed. Here, 2 and a squared are fine. 2 lots of a squared is our numerator, but p to the negative 5, written with positive indices, is really 1 over p to the 5, which is why it's written down in our denominator with a positive index. So question A from example 10. X to the negative 5 is 1 over x to the 5. 3p to the negative 7 is 3 over p to the 7. In question C, we might identify which powers are negative, which is this one and this one. Now, the easiest way to think of this is to write them, and they can become, their positive partnership is when they are changed from becoming a numerator to the denominator. So 7j squared, and that I to the negative 4 can come down to the denominator and become I to the power of 4. H squared can remain there, and k to the negative 7 can come up to the top and become k to the positive 7. Hence, you've made them all with positive indices. The next question, a power to a power is multiply. X to the negative 4 times 2 is negative 8. 2 2's for your y are 4. Now express this with positive indices, and the 8 becomes positive when its x to the 8 is written in the denominator. Lastly, x to the negative 3 and x to the negative 2, multiply means add. So negative 3 and negative 2 make negative 5. You have 2 lots of x to the negative 5. Writing this with positive indices, it's 2 over x to the 5. Lastly, a to the negative 2, that's an a to the 1. Divide means take. So negative 2 take 1 is negative 3. B to the 4 and b to the 8 in division, 4 take 8 is negative 4. Writing this with positive indices is 1 over a cubed b to the 4.